So guys, welcome to our channel once again. We have here these 8 questions to answer on chemical combination. So specifically in this video, we are going to focus on Avogadro's law. So guys, ensure to stay till the end of this video. And just like you already know, at any point where you feel you want to answer the question before we provide the answer thereafter, you can always pause this video and try out the question even before we provide the answer. So let's start with the first question here. It says, during a titration experiment, 0.05 mole of carbon dioxide is liberated. What is the volume of gas liberated? Take the molar volume of gas at standard temperature and pressure to be 22.4 dm cube. So guys, here we're going to zoom into our workspace and try to sort this out together. So before then, let's quickly go ahead and bring up our calculator here. So let's take this here. 1 mole of gas has a volume of 22.4 dm cube. That's the standard volume of 1 mole of gas, guys. So here we are told that 0.05 mole of carbon dioxide is liberated, and want to know the volume that was liberated. So guys, if 1 mole is 22.4 dm cube, so 0.05 mole will be what? So guys, we can simply go ahead and cross this out. So to get the volume, that will be 0.05 mole times 22.4 dm cube over 1 mole. So guys, we're going to point this on our calculator. So let's go ahead and have 0.05 mole times 22.4 dm cube, and that's 1.12. So the volume here is equal to 1.12 dm cube. So that's the answer to this question, guys, and that's option A here, guys. So let's go ahead and wipe this out, and then let's consider the next question, guys. The next question here is question number 2. So guys, the question says, at the same temperature and pressure, 50 cm cube of nitrogen gas contains the same number of molecules as A, 25 cm cube of methane, B, 50 cm cube of ammonia, C, 100 cm cube of chlorine, D, 40 cm cube of hydrogen. So guys, the answer to this question here is option B, and that's 50 cm cube of ammonia. Actually, according to the Avogadro's law, equal volumes of all gases at the same temperature and pressure have the same number of molecules. Therefore, 50 cm cube of nitrogen gas will contain the same number of molecules as 50 cm cube of ammonia at the same temperature and pressure. So let's consider the next question. That's question number 3 here. It says, trioxonitric acid is obtained by the catalytic oxidation of A, nitrogen, B, ammonia, C, non-metals, D, metals. So guys, the answer to this question is option B, and that's ammonia. So let's consider the next question. Question number 4, it says, determine the volume of 2 moles of SO2 at standard temperature and pressure. So guys, let's zoom into our workspace here and sort this together. So at standard temperature and pressure, we know that 1 mole of a substance is equal to 22.4 dm cube. So guys, we're asked to find the volume of 2 moles here. So guys, 2 moles will be, we have to cross this out. So This is the volume. So the volume here will be 2 times 22.4 over 1. So guys, let's go ahead and calculate this. 2 times 22.4, and that's 44.8. So the volume will be 44.8 dm cube. So guys, that's it about this question. The volume here for 2 moles of this substance will be 44.8 dm cube. And guys, that's option B here. So let's wipe this out, and then let's go ahead and check out the next question, and that's question number 5, guys. The question says 35 cm cube of hydrogen was packed with 12 cm cube of oxygen at 110 degrees Celsius and 760 millimeters of mercury to produce steam. What percentage of the total volume of gas left after the reaction is hydrogen? A, 11%, B, 69%, C, 35%, and D, 31%. So guys, let's go ahead and zoom into our workspace here and solve this together. Let's go ahead and write the equation of the reaction first. So hydrogen here plus oxygen here to yield water. So they'll have the ratio 2 here is to 1 here is to 2 here. So in that case, if 12 cm cube of oxygen was used, it means that the volume of hydrogen that will be used is 2 times this 12, and guys, that's 24 cm cube, and then 24 cm cube of this gas will be produced. But guys, in the question we have that 35 cm cube of hydrogen gas was sparkled, so with 12 cm cube of oxygen, which means that we have excess of hydrogen gas being sparkled. So guys, since we have excess of this hydrogen gas being sparkled, the next thing we are going to consider here is what's the volume of this excess hydrogen. So guys, the volume of the excess hydrogen will be this 35 cm cube minus 24 cm cube. So guys, let's go ahead and use our calculator here. So here we have 35 minus 24, and we have 11. So guys, 11 cm cube of hydrogen is in excess here. So with that, we can now get the percentage of hydrogen gas that was left after the reaction. It will be 11 out of the initial 35, then times 100, which represents percentage. So that will be 11 over 35 times 100, and that's, guys, let's see, 11 over 35 is 0.314 times 100, 0.314 times 100, and that's 31.4. So that's approximately 31%. So guys, that's the answer to this question, and here guys, that's the option D. So let's go ahead and wipe this off, and then let's consider the next question, guys. So the next question here, guys, is question number 6. It says, what volume of hydrogen will be produced if 100 cm cube of ammonia is completely decomposed at constant temperature and pressure. The equation for this reaction is 2 molecules of ammonia decomposing to form 1 molecule of nitrogen and 3 molecules of hydrogen. So guys, we are simply just going to use this equation of the reaction here to know the ratio. So let's zoom into our workspace here. So we have 2 NH3 decomposing to form N2 plus 3 molecules of hydrogen. So guys, these are all gases. So having gotten this equation of the reaction, we have to know their ratio, and that's 2:1:3. So guys, it means that when 2 molecules of this dissociates, will produce 1 molecule of this and then 3 molecules of this. So guys, if 100 cm³ is the volume of ammonia here, it means that the volume of this nitrogen will be 50 cm³, since it's half of this, and then the volume of this hydrogen here will be 150 cm³, guys, in this case. So if you are wondering, this will be 2 times 50, and this will be 3 times 50, and this will be 50, since each unit of this is 50. So this is correct. So guys, in this case, the volume of hydrogen that will be produced is 150 cm³, and that's the answer to this question, guys. So here, that's the option B. So guys, let's go ahead and consider the next question. So the next question here is question number 7, guys. It says, by applying Avogadro's law, the volume of gas can be converted into the relative number of A, ions, B, electrons, C, molecules, D, atoms. So guys, the answer to this question is option C, and that's molecules. By applying the Avogadro's law, the volume of gases can be converted into the relative number of molecules they contain. So let's quickly go ahead and consider the next and the last question here, guys, and that's question number 8. It says, for a gas, the relative molecular mass is equal to 2y. What is y? A, the mass of the gas. B, the volume of the gas. C, the vapor density of the gas. D, the temperature of the gas. So guys, the answer to this question is option C, and that's the vapor density of the gas. The relative molecular mass of a gas is twice its vapor density. So guys, y here will represent the vapor density of the gas. So this is where we end this video for today, guys. If you enjoyed this video, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So guys, we also want to encourage you to join our channel membership here on YouTube, as it will help you a lot. We have premium information, guys, for you there. So ensure to join this channel in order to get access to all this premium information. So guys, this is where we'll draw the curtain for today. Thank you for watching this video, and see you in our next one.